Welcome. This video shows a general overview and the core concepts of Echotopia. Echotopia separates your work using projects. If you open Echotopia and go to Project and Home, you will see a list of the latest projects you have worked on. Don't worry if you don't see any projects here. You can create a new project or open an existing one using the buttons on the top right of the pane. Let's open the project titled Medieval Fantasy and explore further. Each project can contain any number of scenes, and each scene includes an image used as a map. We can open the first scene titled Level 01 World Map by clicking the Open button above the map image. This opens the scene editor. The scene here contains the top-level view of a fantasy world in which our story takes place. We can see the map viewport and an empty layers list section. We can create, search, and manage our scene sound layers using the buttons in the top right corner. If we create some layers, we can see a complete scene. On the right of the map view, we find the inspector, which shows us the properties of any layer that we select from the layers list or by clicking it on the map viewport. Now, let's hide some of the layers to get a clearer view and explore the layer concept more deeply. Each layer you see here corresponds to an area on the map. There are also some global layers that function on the complete map. Also, one other important object in the map viewport is the listener, because what we hear comes from the calculations of all the scene's layers and settings in combination with the listener's position. This is one of the great things about Echotopia. You can create an entire acoustic world and then listen to it from any position and perspective. Let's zoom in on our scene and see what a layer is made of. Let's take the Great Volcano layer. This is a circle-shaped layer located in the area of a great volcano in our scene. The first circle marked with the letter A represents the main zone of the layer. When the listener is located within the main zone of a layer, the layer's sound plays back in its original mix. The second circle marked with the letter B represents the fade zone of the layer. When the listener is located within the fade zone of a layer, the layer's sound plays back using processing that simulates the acoustic effects of distance, adding a lot to the realism of the soundscape. We'll show more on that later, together with audio examples. Now, we'll see what a layer is made of. On the right section, we always see the inspector, showing the properties of the selected layer. The layer's properties contain three main parts. First is the transform properties. You can precisely set the layer's position, layer type, and zones using those properties. After that comes the sources section. Here, the sound sources of the layer are defined. Sources are combinations of audio files and their playback behavior, and you can consider them the instruments of the soundscape. As you can see in this screenshot, there are two types of sound sources: loopers and randomizers. We're going to open the looper titled Low Rumble. Looper sources are used in layers to play continuous sounds like ambience recordings, atmospheric drones, noise prints, room tones, etc. In the first section, we find the file container, which shows the file that this looper will play. You can load any audio file from Echotopia's core library or your files using the Add and Remove buttons. Echotopia supports WAV, MP3, OGG, and FLAC audio files playback. The looper can take audio files with up to 8 channels, and its internal mixing engine will expand or downmix the audio file's content to be played correctly on the number of channels that the users set their sound cards or the number of channels the users want to render on a file. This is one of the immersive magic tricks that Echotopia does. You will always produce immersive soundscapes for any number of channels, currently up to 8, no matter how many channels your files have. In the second section, we can set the looper's name. We can choose if we want to apply a crossfade on the loop playback, change the volume of the looper, or change the play rate using the pitch adjuster. Changing the play rate of an audio file uses values in semitones, and it's a standard trick for creative sound design, which can often yield fascinating results. Next is the breathing section. In nature, a sound source might change its general sound level over time, and this is precisely why the breathing module is there. In breathing, you can set the minimum and maximum volume limits that the breathing will use. Those are multipliers that affect the main looper volume. The trigger timer range is given in seconds, and a random number generator uses it to decide when the breathing change will happen each time. The transition duration range is again a random value between the limits you set in the respective fields, and it's used to set the time duration that the volume ramping to the next volume value will happen. By using the stochastic parameters of the breathing module, you can create endless volume changes for the loop that is playing, giving your soundscape a more natural identity. Finally, we see the silencing module. This is similar to the breathing, but it's used to introduce silence periods to the looper. The trigger time range works the same as in the breathing module, and the transition duration range provides a way to set the time to go to silence or start playing again. By using both the breathing and the silencing modules with different values in many loopers, you can quickly achieve a natural soundscape's realism without setting complex and repetitive volume automation curves. Let's return to the Inspector Sources section and see the next source type, the randomizer. We're going to open the randomizer titled Eerie Gusts Pitched. Randomizer sources are used in layers to scatter individual one-shot sounds around the sound field using random position, volume, and pitch. The randomizers are perfect for adding single sounds here and there in your soundscapes, like bird vocalizations, car pass-bys, shooting and explosions, wind gusts, raindrops and thunder, foley's, and any other sound that is not repetitive and has a randomized behavior in the soundscape you are creating. In the first section, we find the file container, which shows the list of files that this randomizer will use to randomly pick a file and play it each time it's triggered. The supported file formats are the same as with the looper, but the randomizer doesn't need multi-channel files as each time it's triggered, it plays back on a random position in the sound field. To manage a file with more than one channel, the randomizer sums up all the file's channels into mono and uses that to play it back. In the second section, we find the randomizer's primary properties. Again, we can set the randomizer's name, but the volume and pitch are set as ranges this time. This is because each time a random file is triggered, we can have it play back using a random volume level and a random play rate, adding more to the realism by creating more variation on the files we already have. A very useful function in this section is the clustering. By using clustering, you can group many trigger events each time the main trigger calls a single event. This is easier to understand with an example. Let's say we want to create a construction site layer for our scene and add a source that plays back the sound of someone hammering nails into a piece of wood. If we add random one-shots of nail hammering in the layer, the result will not be natural, as people tend to hammer nails in groups hammering actions. The same behavior goes for bird vocalizations, machine gun shooting bursts, and many more sound events. By using the clustering functionality, we can simulate this natural behavior easily. The trigger number range defines the limits for creating a random number of triggers, and the trigger timer range defines the gap between those multiple triggers. The drop-down menu below those ranges lets us choose how the timer range is used each time the whole cluster of sounds is triggered. Randomized timer for each event means that when one sound is triggered within the cluster, the next sound will have another random time value picked. Randomized timer for each cluster means that each cluster will have a random time value picked at the beginning of the cluster's playback, and all the sound events in this cluster will have the same gap between them. Clustering is a fascinating natural behavior, and if combined with volume, pitch, and position randomization of isolated one-shot sounds like the thousands included in Echotopia's core library, it can create very believable and ever-changing soundscapes. Moving on to the following sections, the breathing and silencing modules are the same as in the looper. The only difference is that those modules act upon the event level to ensure no fading takes place while one sound plays back, which would be unnatural. Going back to the final section of the layers inspector, we find the acoustics. The acoustics part of the layer properties allows us to define the reverberation and inward occlusion properties, which are the most critical acoustic phenomena of sound interacting with the matter of a surrounding space and play an essential role in how we perceive a space's size, materials, and structure. Acoustics also allows us to define the character of a layer in creative and stylistic ways, significantly affecting the final result's aesthetics. To simulate reverberation and inward occlusion, Echotopia uses the popular and open format of impulse responses. Apart from many impulse responses that Echotopia already contains in its core library, you can find many impulse response files online, taken from famous sites like castles, caves, abandoned factories, architectural marvels, archaeological findings, massive temples, and more. Using this open format makes it easy to expand the naturalness of your scenes or add that extra epic feel your story needs. Reverberation simulates the reflection and absorption of sound from the materials of the space that surrounds the sound sources. It's probably the most critical effect when defining a space's character or the aesthetics of your work. Reverberation also acts as glue for all the sounds on a layer by giving them a similar character and making them fit together naturally. Here, we should mention that all the sounds that Echotopia's core library includes are specially treated to sound more anechoic than in the natural environment, so they adapt fully to the reverberation effect that is set for each layer. This advanced sound technique is proven in psychoacoustic experiments to add realism and boost immersion. Apart from real or fictional spaces, in Echotopia's core library, you will also find some more experimental and exotic reverberation impulse responses that you can use for creative sound designs. Inward occlusion simulates how the sound from the outside of a structure sounds when it passes the materials of that structure and reaches our ears. The sound of a busy street as it's filtered by the materials of our apartment walls, or the sound of a waterfall coming to us filtered through the trees of a dense forest. In Echotopia, the inward occlusion effect occurs when the fade zones of other layers intersect with the main zone of the layer the listener is positioned in, and the listener is positioned in the main zone too. This logic provides a good compromise when the listener is positioned on top of many intersecting layers that the user has set with different inward occlusions. Together with the calculation of how distance affects the sound of the layers that come to the listener and the reverberation inside a space, inward occlusion is the cherry on top that provides the soundscape artist with a way to create believable worlds that sound natural and can be experienced from any position on a scene. A trick that professionals use for fictional worlds and special effects is to load exotic reverberation impulse responses in the inward occlusion module so that sounds that come from the outside of a layer have strange time effects applied to them. A magic veil that surrounds the area, an energy vortex that shields from projectiles, or a special wall of silence used for high-tech espionage, all those and more can be created using that trick. Inward occlusion impulse responses are not easy to find, but worry not, as Echotopia's core library offers a wide range of materials, and we add content continuously. Now that we're finished with the layer inspector and we have a good understanding of how Echotopia creates the sound of our scene's layers, let's see an example of how layers interact between them and with the listener object to produce the final audio output. Let's focus on a specific area of our scene, where the Great Volcano layer intersects with the South Town layer. First, let's see how Echotopia uses the listener object to calculate and render the soundscape from the listener's perspective. As we see here, the listener is located within the fade zone of the Great Volcano layer. The distance between the outer limits of the main zone and the fade zone determines how much the layer's sound decreases in level as the listener moves further away from the main zone and how much the rest of the distance acoustic simulations affect the layer's sound. Acoustic simulations like the increase of the reverberant parts of the layer and the decrease of high-frequency content are, amongst others, parts of the magic when creating a soundscape that can be experienced realistically from any perspective. Simultaneously, the sound from the fade zones of other layers that reach the main zone of a layer is filtered using the inward occlusion of that layer, adding to the realism. Echotopia automatically calculates all those acoustic phenomena according to how you set the zones, offering an easy way to create realistic soundscapes and export the sound at any position on the map. Let's move the listener around and listen to some examples. First, the listener is located in the middle of the Great Volcano fade zone. We hear the Great Volcano layer sources from a moderate distance. Now, the listener is moved inside the Great Volcano main zone. We hear the Great Volcano layer sources on their original mix. In our third example, the listener is in both the Great Volcano and the South Town fade zones. We hear the Great Volcano and South Town layer sources at their respective distances. Finally, the listener is located inside the South Town main zone. We hear the South Town layer in its original mix. If the listener were, at this point, in the South Town main zone and the Great Volcano fade zone, we would hear the Great Volcano sounds from a distance through the inward occlusion filter of the South Town. By using many layers containing loopers and randomizers inside them and setting their main and fade zones according to your design, you can create elaborate acoustic scenes that offer unique perspectives of the soundscape for every listener position. The Start Simulation button at the top right corner of the map viewport allows you to listen to the listener while you edit your scene. Some functionality might be unavailable while the simulation is playing. You'll have to stop the simulation to tweak those parts of your scene further. The Save Scene button allows you to save your scene in its current state. Don't forget to save your scenes right after essential changes so you don't lose your work. The Play button on the Inspector Sources section can only play back the selected layer. This is useful when you tweak a layer, and you only want to hear this layer without other layers or acoustic simulations that consider the listener's position on the map viewport. The Source Submixer button opens up a submixer containing the volume levels of all the layer sources to offer a fast mixing method. Feel free to explore the rest of the buttons and menus on the inspector as we add more with every update. Going back to the Save Scene button, there is a drop-down menu that offers two more options. The Save Scene As option allows us to create a copy of the current scene. The quick render option allows us to render an audio file containing the listener's perspective at its current position on the map viewport. When we select Quick Render, a dialog box with options for the audio file renderer will appear. File name and path are self-explanatory, and you can save up to 8 channels of surround sound at 96 kHz and 32-bit floating point resolution files. Below that, you can set the duration of the output file in seconds. By using the Quick Render function, you can export the soundscape from specific positions of your scenes and import them into other applications like video editors, game engines, virtual tabletop platforms, virtual reality experience authoring applications, the playback list of a yoga or spa studio, digital audio workstations, or any other use. For those who perform their storytelling live, like game masters, audio drama performers and streamers, podcast broadcasters, theatrical sound performers, escape room game masters, or any other kind of live performances, Echotopia also features a live mode. When engaged, the live mode offers a distraction-free view of the map viewport with only the listener and some essential tools. That way, you can focus on your performance and storytelling. Just move the listener around the scene to change what your audience is hearing. On top of the screen is a drop-down menu offering quick switching between your scenes without leaving the live mode. A cool storytelling trick useful in tabletop role-playing games is that you can create layers that give hints for hidden passages. For example, random wind whistling or howling next to a castle corridor, giving up the position of a hidden passage to a secret dungeon. Let the soundscape do your work, and your audience use your soundscapes as a way to interact with your stories. When you want to leave the live mode, you can click on the stop button at the top left corner of the screen. This guide mainly focused on the scene editor, but we should also mention another essential part of Echotopia before this video ends: the library. Clicking the library button on the Workspace tab, we navigate to the library workspace. The first screen here is the Layer Preset screen. Here, you can find professionally made layer presets containing sound sources and acoustics ready to be used in your scenes. Echotopia's core library contains layer presets for any genre and style, and we add new presets with every core library update. You can use Echotopia's soundscape taxonomy to filter the presets by author, genre, style, setting, and ecology. You can also search the list of all or filtered presets. By clicking on a preset, you see its contents and settings, preview how it sounds, and you can even render it to an audio file. The second screen on the library workspace is the Asset screen. Here, you can browse the contents of Echotopia's core library, containing thousands of sounds to use in your creations. Echotopia comes with all the Soundfellas sound libraries plus more content made explicitly for Echotopia. At the time of the making of this video, Echotopia's core library contained more than 20,000 sounds custom-made at the Soundfellas studios, covering all genres and styles. All core library updates are free until a new key version of Echotopia is released. The users who upgrade to the new Echotopia key version are eligible for more free core library updates until the next key version is released. By using the Add Location button on top of the locations list, the user can add other custom locations with content. Those locations will appear on the file browsers when the user chooses files for use in loopers, randomizers, acoustics, and more. It's a convenient way to create shortcuts to find them fast when you add content to your scenes. This concludes the general overview and core concepts video guide for Echotopia. Echotopia is a new and innovative soundscape designer application, so we urge you to subscribe to our channel and select to receive updates, as we plan on adding many features and innovative technologies that will enhance your creativity and elevate the experiences you create for your audiences using immersive soundscapes from Echotopia. Until next time, thank you for choosing Echotopia.